What is gradient of a scalar field and what is the geometrical interpretation of gradient of scalar field and what are the physical significance of gradient of a scalar field. In the previous video we have discussed about scalar field. Suppose a scalar field changes from A to B along the direction dr and the scalar field changes from A to C along the direction dr prime and the scalar field changes from A to D along the direction dr double prime. So what will be the maximum rate of change of the scalar field? The maximum rate of change of scalar field will be along this direction. That means the direction where the slope is maximum. Okay, and this is the geometrical interpretation. That is, the gradient is defined as the maximum rate of change of scalar field at a point. This is the geometrical interpretation. And what is the physical significance? The physical significance is that the gradient of a scalar field, we write it grad phi, and that is equal to the change of the scalar field with r, and it is maximum. That means maximum rate of change of the scalar field at a point. And since it has a direction, so you multiply a unit vector here. That means gradient of phi is a vector quantity. Grad phi is a vector quantity. So you have to remember that gradient of a scalar field is a vector quantity and n cap is the unit vector along the displacement dr in this direction where the displacement is minimum. Now we will discuss the physics of the gradient of a scalar field. Consider a scalar field, suppose phi, undergoing a displacement dr along this direction from A to B. Suppose from a point A having coordinate x, y, z, the coordinate of A is x, y, z, and it changes, the scalar field changes from A to B, and the coordinate of B is x plus dx, y plus dy, and z plus dz. Okay, so what will be the total change in the scalar field? Total change in the scalar field we write d phi, that is equal to the change in scalar field with respect to x into dx plus the change in scalar field with respect to y into dy plus the change in scalar field with respect to z into dz. Suppose this is equation number 1. The displacement of the scalar field dr, that can be written as I into dx plus j into dy plus k or k cap along z, that is dz. Suppose this is equation number 2. In the previous video we have discussed about del operator. Del operator is equal to I cap del by del x plus j cap del by del y plus k cap del by del z. And now you take del of phi. Del of phi will be equal to I cap del phi by del x plus j cap del phi by del y plus k cap del phi by del z, because when you dotted I with I, it will be equal to 1, j with j, it will be equal to 1, and k with k, it will be also equal to 1. Then what will be the, because phi is a scalar function, it is not a vector function, it is a scalar function. So only you multiply phi here in this del operator, you multiply phi here, here, and also here, because there will be change of the scalar function along the 3 directions. Now take the dot product of del phi with dr. What will be the dot product? If you take the I cap dot I cap 1, j cap dot j cap 1, and k cap dot k cap 1, so this will be equal to del phi by del x into dx. You take the dot product of this and this. Similarly, del phi by del y into dy plus del phi by del z into dz. Suppose this is equation number 3. Now if you compare equation 1 and 3, in equation 1 you have d phi is equal to del phi by del x into dx plus del phi by del y into dy plus del phi by del z into dz. And in equation 3 also, in the right hand side you have the value of d phi. So this will be equal to d phi. So d phi will be equal to del phi dot dr. Okay. And if you take the magnitude in terms of magnitude of the dot product, it will be equal to magnitude of del phi magnitude of dr into cos 0, because the change in the scalar function, here we have taken the change of the scalar function is along the direction of dr. So theta will be equal to 0 degree. And since cos 0 is equal to 1, then you may write d phi by dr, that will be equal to del phi, and this is your grad phi. So grad phi will be equal to the maximum change of the scalar function, that is d phi by dr max, or grad phi you may written as del of phi. So grad phi either you write in this way or in this way, or you may write grad phi is equal to I cap del phi by del x plus j cap del phi by del y, k cap del phi by del z. These three equations are very useful in physics, so you have to remember the mathematical notation for the grad phi or gradient of scalar field, either in this form or in this form or in this form. This will be very useful in physics. And in the next video we will discuss about divergence of vector field. Thank you.